What's up, team? Today, let's talk about segment addition and midpoints. Our learning target says I can apply the segment addition postulate to find the length of segments, and I can use the definition of midpoint to find the length of segments. I got a few reminders right above me here. So to find the length of two line segments, simply find the sum of the two lengths. Additionally, the midpoint divides a line segment into two congruent segments. The midpoint chops the segment in half. That's the core of our lesson today. Let's dive into some details. Okay, the first thing I want to talk about is this word postulate. It's not something you have to memorize, no vocab quiz, but I want you to be familiar with it. So a postulate is just a statement or a rule that is accepted without proof. Now, generally, you can't just make up a postulate kind of willy-nilly and be like, yeah, this is true because it's a postulate, so you have to accept it without proof. No, so generally a postulate is something so simple that it doesn't even need a proof. Something so basic, and you'll see exactly why we're calling the segment addition postulate a postulate here in a moment. Okay, the segment addition postulate essentially is this. If you have some line segment, in this case it's AC, and there's some point B in the midst of AC, and your goal is to find the length of AC, but you only have AB and BC. In this case, AB is 12, whereas BC is 2, and you are tasked with finding the length of AC. The segment addition postulate says that AB plus BC equals AC. So this stuff plus this stuff equals the whole thing. So in this case, we sub in 12, we sub in 2, and it's 14. So again, postulate, super simple. I'm hoping that this is a no-brainer. This stuff plus this stuff equals the whole thing. I have a more formal definition in my notes. If you want to check that out, feel free, but this is the segment addition postulate in work. Okay, midpoints. The midpoint divides a line segment into two congruent segments. Pretty straightforward. So if I say B is the midpoint of AC, that means I have some line segment AC, and if B is the midpoint, then B is exactly in the middle. So this length AB is exactly the same as this length BC. So if you were given some line like this, and you were told that AB is 6, and you were told that B is the midpoint, and you need to find AC, well, you would just do 6 plus 6 because we know that these two distances are the same. So this would be 12. So AC would equal 12. Okay, let's do an example. This example here says if y is the midpoint of WZ, so we have some line segment WZ and y is right in the middle. It's going to chop it right in half. We know that YZ equals x plus 3. So when you see letters like this, that means the length of segment YZ is x plus 3. The length of WZ is 3x minus 4, then find the length of WZ. All right, this is confusing. There's words, there's a lot of letters, there's a lot of things happening here. So our very first step when we're solving something like this is draw a picture. Always, particularly in geometry, draw pictures. It's going to make your life so much easier. So we know that y is the midpoint of WZ. So that means we have some segment with W at one end, Z at the other end, and y is right in the middle. Okay, even though it doesn't look like it. It's in the middle because it's given, so let's roll with that. We know that YZ has a length of x plus 3. So let's find YZ, and we know that this is going to be x plus 3. Okay, we also know that WZ is 3x minus 4. So that's the whole distance, 3x minus 4. It goes all the way to both ends. Then we need to find the length of WZ. So this is our unknown. Did something wrong? Bummer. Okay, I'm back. I didn't actually make a mistake. I just misinterpreted what was going on. We're good. So WZ, we're trying to find that length, the true length, and not just in terms of x. So we're going to find the x and the sub it in. So we're good. We're straight here. So what we know is that y is the midpoint of this business here. That means that YZ is congruent to WY. Therefore, we can say that WY is x plus 3. So both of these distances are x plus 3. Now, using the angle addition postulate, we know that WY plus YZ equals the whole thing. So that means x plus 3 plus x plus 3 equals this. So we're going to set up an equation now. We know that x plus 3 plus x plus 3, of course you could do some multiplication and stuff there, clean that up, and we will here in a bit, is going to equal 3x minus 4. So combining like terms, we know that 2x plus 6 equals 3x minus 4. And when you solve this, you're going to, let's see, well, how do we want to do it? We'll add 4 to both sides, and we'll also subtract 2x from both sides, and then we're going to learn that x equals 10. Now, this is not our solution. We're not done yet. We're trying to find the length of yz, and this is like where I messed up a moment ago in interpreting this. So now all we need to do is take this x equals 10, and we're going to plug it in to this distance here, 3x minus 4. How come 3x minus 4? Because we know yz has a length of 3x minus 4. So when we substitute 10 in, we learn that 3 times 10 minus 4 equals 26. Therefore, wz equals 26. And generally, we'd say 26 units in this case. Okay, let me know if you have any questions, but this is the segment addition postulate, and this is midpoints.